Welcome back to C++ session. Today I am going to discuss about functions in C++ as well as argument passing mechanism in C++ functions. In daily life we are coming across number of functions. For example, walking is a function, driving is a function, eating food is a function. Function is nothing but a set of instructions which is used to perform an operation. For example, I have a function. Eating food is a function. I am going to eat chicken. Again I am going to eat rice. Again I am going to eat ice cream. Now at morning I am so much hungry. I am calling this function. At lunchtime I am horribly hungry. Again I am calling this function. At dinner time also I was hungry. So I am calling this function. So with the help of functions it is possible to achieve something known as reusability. Now I am executing this function. After executing the function, I supposed to inform the user that boss, I have executed the function. So this function need one more things which is known as return type of the function. So a function should have a return type and function have a well defined name and function have the arguments. These arguments are either input or which is used to process, or we are processing these arguments inside these functions. Now we can write some small function and we can see what is the need of a function. Now we have studied what is function. Now we are going to study what is the need of a functions. I am going to write one small program. I wanted to calculate sum of two numbers. For calculating the sum of two numbers, I am going to write a very small program. I have a main function. Inside this main function, I am declaring two variables. Int I is equal to 10 and I am declaring one more variable j which is equal to 20. My intention is that I wanted to calculate sum of these two numbers. So that I am declaring one more variable int sum which is equal to I plus j. Now I am just printing what is the sum with the help of cout sum and del. Next time what I am going to do is, again I wanted to add some more numbers. Again I wanted to add 100 plus 200. Again I am extending this function like int p is equal to 200 and q is equal to 300. Here I am writing sum which is equal to p plus q. Here again I am writing cout sum and del. Now we can closely observe this function. You can see that this step is common here as well as here. So again maybe tomorrow I am going to add some more numbers. I wanted to add 1000 plus 2000. Again I need to repeat the same line. So instead of that, here I am thinking like this way of writing a program is an inefficient way of writing the code. So what I am doing is, instead of writing like this, I am going to write a function. Inside that function I am performing this operation. Now we can write a function. The name of the function is add numbers. Now here I am going to add two integers. So this function has to collect two integers. Here I am writing int n1 comma int n2. Inside this function, I am going to perform this operation. Here I am writing int result, which is equal to n1 plus n2. Here I am writing return result. Since this result, which is of the type integer, I am collecting this over an integer. Now instead of writing here like this, we can just replace this line with the function call. Here I am writing add numbers I comma j. Here again in this line also I am replacing with help of this function call. Here I am writing add numbers p comma q. Now we can see how this function is working. Whenever there is a function, a stack frame is getting created for all the variables of this function. Now let's see, since I have some local variable available here, these local variables are getting memory inside the stack frame of this main during the runtime. Here I am going to draw the stack frame of this main. Assume this is the stack frame of the main, which have one variable integer I. Assume this address is starting from a location 7000. So this I, which is available inside a location 7000 minus size of integer. So assume we are using a 32-bit processor, size of integer is 4 byte. Here this location will be 6996. So this value will be available here. Now again j, which is available inside again stack memory segment, the value will be 20 and the address of this j will be 6992. Again this sum also available inside the stack memory segment and the address of that sum will be available inside the stack memory segment and the address of the sum will be 6988. Now there is a function call. This line you can see a function call. Okay. Now there is a function call. The stack frame of this add number also getting created. I am drawing the stack frame of add number function, which have this n1. n1 is getting copied over here. This is n1, that is 10. Again, which have n2. n2 which is 20. Again which have a local variable result. So result which is available here. Now you can see here this value which is getting copied over here. This is this I which is getting copied over here. Again see this j that also getting copied over here. Now there is a local variable result. This result is available inside the stack memory segment of add numbers. Okay. Now here I am performing this operation. Result is equal to n1 plus n2. n1 is available here, n2 is available here, n1 plus n2 will be 30. 30 will be available here. Now here I am writing return result. This return statement, he will keep this result inside the accumulator. So this accumulator registry which will contain 30. Now this sum, it will collect the sum from the accumulator. According to the computer, according to the processor, the sum will be sum equal to move accumulator to sum. So this accumulator value which is getting copied into this sum. So this is 30. Now you can see that this value we are taking a Xerox of this value, or we are taking a photocopy of this value, and we are passing into this arguments. Again we are taking a photocopy of this j, we are passing into another function. This kind of argument passing mechanism which is called by value. Call by value is nothing but taking a copy of this argument and passing into the function. Now you can do some operation inside this function, and you can return back, and you can collect it over another function, and you will get the output. Now you can see this function is getting called with a value. That is why this kind of argument passing mechanism which is known as call by value argument passing mechanism. This is one of the argument passing mechanism in C++ program. We have another argument passing mechanism that is known as call by reference. We will be explaining call by reference in our next sections. Thank you for watching the video.